Hello friends, our today's point is derivatives. First write down the title. Derivatives. Friends, we have already discussed basics of this chapter in our previous videos. Here we will see the definition, okay, and few examples. Friends, from our previous videos, what we have seen, the velocity is nothing but derivative calculated from the distance function. Okay, this is, or it is a slope. Okay, alternative names for derivative is nothing but finding slope. Okay, finding slope of f of t at t. Okay, is nothing but derivative. In case of distance, this is nothing but velocity. That's it, my friend. Don't need to save it. Friends, in our previous video we have seen that just by using a game of numbers we have proved that if distance is t square, okay, means something like 1, then sorry, 0 1 4 9, okay, like this, then the velocity is going to be 2t. Okay, it also means its derivative of t square is nothing but 2t, or it also means slope of this function, okay, is nothing but 2t, okay, at time t. Similar case is about the sin t. If function is a sin t, okay, distance function is sin t, then velocity function is going to be cos t. Okay, or derivative of sin t is nothing but cos t, or slope of sin t at time t is nothing but cos t. Okay, these are the cases. Here I have written the definition of the derivative. Okay, this is a very simple definition. See, it have two parts. Okay, this f dash t is a alternate symbol for the derivative. It is similar as df by dt. Okay, this symbol is very useful in case of when there is a long chain of the equation. Okay, for example, just like f dash of x plus 2 f dash of x. Okay, something like this. Then the this form is difficult to write down. That's why we can use f dash of t instead of df by dt. Also useful in case of finding in case of multiple derivatives. Okay, you can just write down, for example, just a second, in case of d square f by dt square. Okay, you can just write down f double dash of t. That's it, my friend. That much simple is this. Now focusing on this equation, okay, on this equation, it has two parts. One part is this df by delta t. Okay, this is nothing but delta by delta by delta t, and the another part is this limit del t tends to 0. Okay, instead of del t, sometimes we or you can write down del t can be replaced by h. Okay, same thing. H or delta is small increment in time. Okay, that's it, friends. Now focusing on this equation, I will explain. Just a second, you don't need to save it. Okay friends, I have drawn on graph f of, just a second, f of t, and this is t. Okay, this is one graph, and another one graph is a straight line. Okay, f of t and t. And if I will ask you, this is some simple f of t. Okay, I simple, it is a line, just write down it is a line. Okay, I will ask you to find out the slope of this line. Let it is y equal to mx, or f of t equal to mt. Okay, simple equation of line. And if I will ask you what is the slope of this equation, okay, or slope of this line, what will you do? You will choose 2 points. Okay, suppose this one point, this one point. Okay, and you will just draw something like this, and you will take this height difference. Okay, del delta f. Suppose it is at f1, this is at f2, and here it is t1, and this is t2. Okay, delta f by delta t. Okay, you will simply find out this difference. Okay, f2 minus f1 divided by t2 minus t1, and slope will be m. Okay, that's it. No any requirement of limit delta tends to 0. Okay, that much simple is this slope. Okay, in for finding out, or you can write on v of t. Okay, for finding out the slope of line, we don't need a calculus. Okay, it is common sense to find out the slope of a straight line. But in case of a curve, just a second, I will clear this file, open. We don't need to say it. Where is the curve? Okay, see, now the situation is changed. See, this is a curve, not a straight line. Okay, and if I will ask you to find out the slope, suppose at this point. Okay, at point t, what will you do? Friends, it is just difference is, just take another point to understand. Okay, I will ask you to just take another point. Okay, way is the same as that of finding the slope of line. Okay, we will choose 2 points. Just a second, let's this point. Okay, we have chosen 2 points. Now try to find out the slope. Okay, similar case as that of line. Okay, if this one is, okay, f of t plus del t. Okay, f of t, here t. Okay, and this one is f of t, sorry, t plus del t. Okay, in case of line, what we did, we had written just t1 and t2, or f1 and f2, but I will write down here. You can write down anything, but to in order to understand, I will write down del t. Okay, small increment in t, which is del t. Now friends, find out the slope of this line, f of t plus del t. Okay, minus f of t divided by t plus del t minus t, which is nothing but del t. Okay, now is it the right slope of this curve at this point? Friends, it is not. Okay, this is just average slope in of this curve in between this t and t plus del t points. Okay, now I want the right slope. What I will do? I will shift when I will shift this line slightly here. Okay, by keeping this point as that of previous. Okay, I will not move this point. I will just move this point. Okay, by shifting slightly here. Okay, and it means I am reducing this del t. Then our line, okay, required slope will get closer. Okay, when I will shift again smaller, again. Okay, finally I will get this line. Okay, when del t becomes 0. Okay, means limit del t tends to 0, will get the actual v of t, or you can say df by dt. Okay, this is the required slope, okay, of this curve. On, in case of this curve, you have to just write down limit del t tends to 0. Okay, this is the way of finding of this slope of the curve. That's it, friend. We have already discussed this in our previous videos. Now moving to the next. Friends, average velocity. Okay, one more important thing. This is nothing but we have seen that in case of curve, this delta f by delta t is just average slope or average velocity. Okay, but at the exact when we put limit del t tends to 0, okay, to this, okay, this it becomes derivative or slope. Okay, see here, and or velocity at exact point t. Okay, we have seen in our previous videos. Just a second, we don't need to save it. Okay, this one is average and this one is, see, average. This one is instantaneous. Okay, or velocity at exact point. Okay, this will just give average. One more important thing, this symbol, okay, df by dt is get invented by Leibniz, and calculus is get invented by uh, Mr. Newton. Okay, he was a great scientist and mathematician. The symbol of even integration is invented by Leibniz. Derivative might not exist, but in case of in some cases this delta f by delta t is exist in every cases. Okay, there is no problem. In most of the cases delta f by delta t is exist, but when you sometimes you trying to put this del t tends to 0, this equation df by dt or resulting answer sometimes becomes 0. For example, suppose some number n is at, after putting this del t, and when you put del t 0, you'll get infinity sometimes. Okay, there it means derivative does not exist in that cases. Okay, file open, we'll move to the next. Now friends, here we will find out the derivative of polynomial, okay, of x raised to n. Simple as by referring to the definition of the derivative. Okay, f of df by dt is equal to, or here f t is replaced by x. Okay, that's why df by dx is limit h tends to 0. H is nothing but similar delta x. Okay, h equal to delta x, don't get confused. Similar in case of del t. Okay, let h equal to del t. Similar here, delta x. Just a second. X plus h means f of x plus h minus f of x. Here, just a second. Here, what is our f of x is? Here, our f of x is x raised to n. Okay, divided by h. That's it, friend. X raised to n we have. Okay, only one thing we need to do is just to expand this x plus h whole raised to n. Okay, it can be done by using binomial theorem. Okay, just a second, I will take a new window. See here, x plus h raised to cube. Okay, suppose I want to find out one, Pascal's triangle. I think if you don't know, see here, 2 plus 1 is 3, 2 plus 1 is 3. Okay, it is for power 1, this is for power 2, this is for power 3. Okay, Pascal's triangle. Okay, these are the used as coefficient. Just write down maximum power to the x cube plus reduced power by 1 x square. Write down this coefficient 3. Then this reduced power give it to the h. Then plus third coefficient 3. Reduce the power of x by 1. Then it becomes 1. Just give it to an remaining to the h. It becomes x square. Plus write down coefficient. Then reduce the power of x by 1 and give it to h cube. Okay, that much simple is this. In case of x plus h raised to n. Okay, x raised to n plus the coefficient is same as the power. Okay, see here 3, that's why here 3. It means n into, just a second, reduce the power of x by 1, n minus 1, give it to h. Okay, plus dot dot dot, and finally h raised to n. Okay, see here h raised to cube, that's here h raised to n. That much simple is this. Okay, file, open, you don't need to save it. Okay, this is the case. Now minus x raised to n this divided by h. Okay, we have expanded this equation here. That much simple is this. When you solve this x raised to n will get cancelled with this, and the remaining thing is only this will get remained after dividing by h and putting the value of h. Okay, what you will get in x raised to, just a second, you can try yourself. See here, n x raised to n minus 1 divided by h. Up to that, this is okay. This h will get cancelled. Okay, uh, and power of h after this plus sign are going to be increasing. Okay, for example, h square by h. Okay, h and one power will get cancelled, and when you put h, value of h 0 here, then this term will get 0. Okay, and even terms after this term will all become 0. Okay, only remaining thing is this, because h will get cancelled. Just a second, this is n, this h will get cancelled, only n x raised to n minus 1 is remaining. That's why derivative of x raised to n is nothing but n into x raised to n minus 1. Okay, see here, that's it. Don't need to save it. Friends, in up to this we have seen much about derivative. Okay, means introductory part, definition, what is average, what is instantaneous. Okay, difference between straight line and curves. Friends, in our next video, we'll see application of this calculus in economics. Okay, thank you. See you in next video. Hello friends, our today's point is derivatives.